Welcome to Dynamic Foundry Group. Today we are going to see a small video on how to manufacture the 35 by 22 ductile iron grade casting. So let us start the video. Importance of achieving this 35 by 22 ductile iron grade. Most of the time in ductile iron it is easy to produce the higher grade like 500 by 7, 600 by 3 grades where the perlite requirements are on higher side and which can be achieved by adding alloying elements like copper, manganese, and controlling cooling rate of the casting. So it is very easy to produce higher ductile iron grades. However, producing lower grades in ductile iron is always a challenging task as it requires higher ferritic structure, which can be achieved only by reducing and controlling manganese percent on those side. So producing lower grade in ductile iron is a great challenge and need stringent process control. To reduce perlite and to increase ferritic, one has to control manganese percentage below 0.15 to 0.2%, which is a very big challenge in melt shop. It needs stringent controls over raw material quality, especially CRCA and runners. Hence, producing lower ductile iron grades like 400 by 15, 400 by 12, 35 by 22 are big challenges. We are going to see some important tips in this video how to make 35 by 22 grade in ductile iron. Raw material control. First, we are going to see what is the raw material control required in making of 35 by 22 grade of ductile iron. Most important aspect in manufacturing this 35 by 22 ductile iron grade is to have lower manganese CRC availability. It requires CRCA with manganese less than 0.15%. For that, consistent source of CRCA is must. If you need to use runnerizers to support CRCA, then you need to use from same grade or from 400 by 15 grade only to control manganese percentage below 0.25 below 0.2% max and below that. Hence, it is suggested to use 100% lower manganese CRCA to produce this 35 by 22 grade. Also, controlling copper and chromium in traces is a bigger challenge in achieving this grade. Chemistry. Controlling the chemistry is another challenge in achieving 35 by 22 ductile iron grade. Final chemistry which I propose is carbon 3.6 to 3.7, silicon 3.4 to 3.5, manganese 0.15 to 0.18, sulfur 0.05, 0.025 max, phosphorus 0.04 max, copper 0.01 max, chromium 0.01 max, magnesium 0.03 to 0.035 max for the last box. Here carbon, silicon and manganese plays an important role, whereas copper and chromium in traces need to be controlled. Inoculation. Inoculation practice plays an important role in achieving 35 by 22 ductile iron grade. Using BIRE inoculant 0.35 to 0.45% will help you to give more ferritic structure along with more nodal count. More nodal count will always give you better ferritic structure or more ferritic structure, which will help you to get desired properties of 35 by 22 grade. You can also use barium based inoculation, but the results with BIRE are much better than that of barium based inoculation. Higher is the nodal count, more is the ferritic structure, and hence better results can be achieved. Cooling rate or cooling time. Cooling rate is important factor in improving the ferritic structure in the grade. Hence, you need to increase cooling time and reduce cooling rate, which will help you to increase ferritic structure in the matrix. Now you go to the second part, that is outcome results. What should be the outcome results if you follow all the things, that is chemistry, charge mix, inoculation, and cooling rate? What will be the outcome? With above process, we can get results which are expected for the ductile grade of 35 by 22R. Nodality above 90%, nodal count around 350 to 450, perlite is less than 10%, ferritic is about 90%, and hardness is will be in range of 145 to 165 bhn. Most important measurement of the success of this grade is the result of physical properties which can be able to achieve with above process control. The tensile strength is expected around 400 to 450 Newton per mm square, whereas elongation expected is 22% minimum. Some important tips. Apart from this process control, I am just putting up some important tips from my practical experience that I have seen in my career so far. So you can also take some more important tips for achieving this grade by doing some of these actions to fine tune the achieved result if they are not as per grade. Number one, you can add STR inoculation up to 0.05% in the stream to increase the ferritic structure. So it is very important to add some stream inoculation up to 0.05% in the stream of the metal to increase the ferritic structure as a secondary inoculation, which helps you in reducing hardness, increasing the ferritic structure, and achieving desired properties. You can keep bath silicon 1% instead of 2% and add some ferrosilicon granules in the treatment ladle, which will not only make up the late silicon addition but also act as an additional inoculation, which promotes ferritic structure in the matrix. So, this is another important suggestion I'm giving. If you're not achieving these properties, you can reduce the bath silicon in the silicon percentage in the bath and increase it during the treatment with granules in the treatment ladle so that some effect of inoculation, late inoculation will be get added to your metal, which will promote ferritic structure in the matrix and help you in getting desired results. Next tip is you can add some pigine if available with lower manganese, or you can add solar metal with lower manganese to promote ferritic structure in the matrix. Another tip is you can increase cooling time, that is more knockout time to reduce pearlitic formation and to promote ferritic structure or ferritic matrix in the microstructure. So these are some of the important tips which can be used for achieving this we can say results for this grade of 35 by 22, which will help you to additionally to achieve this 35 by 22 ductile and grade. So I'm thankful to Mr. Keshavji from Bikaner Engineering Works, Jaipur, for giving me some important inputs to make this video. This video includes some data from him, from his trials, and some remaining data from the trials conducted by myself, which I have accumulated and make this video for you. So thank you very much for uh, being a part of this video, and thank you once again for patient hearing. Thank you.